Hey everyone, and welcome back. I am absolutely thrilled you're joining us today because we're tackling one of the most fascinating subjects in modern tech. We are demystifying robotics. Now, if you happen to be studying the Basic 7 computing curriculum, specifically Strand 4, Substrand 3, then this explainer is basically custom built for you. But, even if you're just here out of pure curiosity, stick around. I promise you a really eye-opening tour of how these machines are making a massive, real-world impact right this second. We're skipping the sci-fi movies and looking straight at the facts. Okay, let's look at today's roadmap real quick. We'll start by meeting the modern robot, compare fixed versus mobile types, and then explore their real-world impact. To wrap things up, we'll weigh their big advantages against 7 key challenges. Section 1. Meet the modern robot. So, picture this. Imagine you have a machine at home that can sweep your entire compound and completely weed your bushy lawns, all while you just sit back and relax. Would that make life easier? I mean, of course it would. And the crazy thing is, this isn't just some futuristic fantasy anymore. Machines that do exactly this are available and operating today. It's relatable, everyday scenarios like this that make robotics such an incredibly crucial field to study. And that brings us to our core definition. What actually is a robot? Fundamentally, it's a machine programmable by a computer that's capable of carrying out complex tasks automatically. Now, they can be guided by an external control device, or that control can be embedded deep within the machine itself. But generally speaking, most robots are designed to do things that are either super repetitive or just way too dangerous for a human being to handle. Moving on to Section 2, Fixed versus Mobile Robots. Here is how the Basic 7 curriculum breaks down the 2 main categories. On the left, we've got fixed robots. Think of industrial arms that are literally bolted down to solve problems from one single position. Then, on the right, we have mobile robots. These guys navigate their environments using wheels, tracks, or even mechanical legs. Section 3. Robots in the real world. First up, education. You might be surprised, but robots are actively used right inside the classroom for learning and teaching. They're fantastic tools for boosting students' interest in STEM subjects, science, technology, engineering, and math. Students can actually assemble these bots hands-on, which is a brilliant way to learn complex programming and algorithms. Now, stepping out of the classroom and into the fields, let's talk agriculture. Manual farming tasks like tilling, harvesting, and weeding are just downright exhausting. But today, robots are stepping in to handle that tiring manual labor. We've got mobile robots rolling through rows of plants, using sensors and cameras to actually tell the difference between a healthy crop and weed. They can thin out maize seedlings and even monitor the health and grazing patterns of livestock. Then, of course, there's the absolute powerhouse of robotics, manufacturing. I mean, imagine a human trying to lift heavy metal car parts all day long. The physical strain would be massive. But heavy-lifting industrial robots? They are completely tireless. In manufacturing, they operate 24 hours a day with unbelievable speed and durability. They're super flexible, taking on painting, welding, material removal, and packing, and they do it all without making mistakes. We also see significant adoption in the military sector. Factually speaking, armed forces around the globe use robots in their daily operations. This ranges from armed robot vehicles used for combat to deploying drones that search environments for incoming threats. They even use specialized bots to check on colleagues in trouble or haul heavy military supplies across really difficult terrain. Now, I've got a question for you, and honestly, this is one of my favorite real-world examples. Have you heard of Ghana supplying blood and medical products to hospitals using drones? It sounds wild, right? But yes, it is a reality, and it is a massive success story in modern healthcare. The health sector is actually utilizing robot drones to rapidly deliver critical supplies, like blood and medicine, to remote or hard-to-reach hospitals. But healthcare robotics goes way beyond just deliveries. We have robots assisting in complex surgeries with pinpoint precision and machines specifically developed to accurately mix medicines, which completely removes the very real danger of human error. And robotics trickles right down into our everyday utility, too. We've got drone robots taking high-quality photos and videos at events. There are even robots developed to cruise down library shelves, sort books, and search for specific titles for you. It's totally redefining the workload for human librarians. All right, Section 4, the big advantages. So why are industries so eager to adopt these machines? Well, the benefits are practically undeniable. Robots work continuously without ever getting tired. They don't need environmental comforts. They don't care if there's air conditioning or even lighting. They offer repeatable precision every single time. They can process multiple tasks simultaneously, and maybe most importantly,
they can work safely in hazardous environments that would be incredibly dangerous or even lethal for us humans.
Section 5. The 7 key challenges. Now, as much as we love the benefits, this technological revolution isn't perfect. According to the Basic 7 curriculum and leading technologists, there are exactly 7 major challenges, or demerits, associated with modern robotics. Let's break them down. First, we kind of have to weigh those amazing physical perks against the operational realities. Yes, absolutely, robots are tireless and precise, but on the flip side, they are incredibly costly to build and purchase. Plus, they suffer from inflexible programming. Basically, a robot cannot do things it wasn't specifically coded to do. If a situation falls outside its programming, it simply cannot adapt on the fly the way a human mind can. And these limitations have some pretty massive socioeconomic impacts. While they do replace human workers and unfortunately increase unemployment in certain manual sectors, they're also super expensive to implement and replace. And when they do break down, work stops entirely. Like we mentioned, they're rigid, unable to do unauthorized or unprogrammed tasks. And eventually, when these machines reach the end of their lifespan, discarded robots produce a massive amount of electronic waste. Which brings us to one final, really vital question to think about. As robots continue to dramatically boost our productivity, but simultaneously create massive electronic waste and replace human jobs, how are we going to balance this incredible technology in our future? It's a complex puzzle for sure, and it's one that your generation is going to be at the absolute forefront of solving. Thank you so much for hanging out with me for this explainer. I really hope this breakdown helped you grasp the incredible world of robotics. Keep questioning, keep learning, and I will catch you in the next one.